All right, so we want to find degree and behavior and y-intercept of these things. So yesterday we started by multiplying all the first terms together. So let's identify the first terms. This one is just x squared. That one is 2x. This one is x, but to the third, bless you. And then when you multiply across, you get 2x to the what? 6, right? Because that's 1 right there. So 2x to the 6. And we'll use that information in just a second. And then we want the last term, and so we multiply all the last terms together. This one, this one, this one. So that's a -2 times a 4 times -3 cubed. So during your order of operations, you would do this first. That's -27. And then in my brain, I say, okay, it's easiest to do -27 times -2. So that's positive 54. And then times 4. Do you ever do math like this? It's a trick. You ready? I mean, it's not really a trick. It's just a strategy. 54 times 4, I can't really do that in my head so well, but what I can do easily is break 54 into 50 plus 4. 50 times 4 is 200. 4 times 4 is 16, so it's 216. Do you ever do that in your brain? No. Yeah. Oh, someone said. So it's basically just distributive property. 50 times 4 plus 4. Anyway, if you didn't have a calculator at your disposal, you could break down numbers and multiply them like that. It's easier. I think so. So 216. Then what are we going to do with all these pieces of information for the degree? We just read off from that first term. What's the degree? Yeah, 6. And then end behavior is a combination of two things, two pieces of information. One is your degree even or odd. Even, very good. And then the other one is your A positive or negative? Okay, so what's the end behavior for even degree and positive A? Up, up, right? Just like x squared's graph is up, up when it's positive and it's even. And then the y-intercept, yeah, very good, 0, 216. Okay, who ninja'd that problem? Who had all those answers? Very good, very good, very good, very good. Does anybody need this up anymore? Are there homework questions? Someone did tell me I made a mistake somewhere on the key. I don't remember what it was. Bye, Hannah. Did anybody do the homework? Oh, yes. Someone lied in third period about doing the homework. I was like, it's not even a grade. Like, I just want feedback, like, so I know if people did or not. And he was like, what's the point of lying? Okay. It's just good for me to know where we're all starting. Are we all on the page, same page or not? You did the homework. Good job. All right, so no questions on the homework? All right, we are today going to, this is a really short lesson. There's just 2 examples. We're going to look at some graphs and read information off of them. And then tomorrow we're going to do the reverse. We're going to be given a function and we're going to make the graph ourselves. Bless you. Oh, sorry. All right. So we're just going to kind of learn by doing, right? You have all this information right here, and we're going to refer to it as we do a problem. So, look, and I don't know if you noticed, these are lettered wrong. This should be A, B, C, D, not A, A, B, C. Yeah, abaca. It should be abaca instead of abaca. Yeah. These are the directions for your graphs. We're going to A, state whether the degree of the function is even or odd. B, use the graph to name the zeros and their multiplicity, which I will explain to you. C, state the minimum possible degree and write the function in factored form. And then D, estimate the domain and range. We're going to be doing all these things. It's a beautiful day. So A asks me for, is the degree even or odd? So here, odd, how do you know? The end behavior is opposite, right? Very good. So the degree is odd, okay, which means it could be cubed to the 5th, to the 7th, or whatever. Okay, and that, if you forget that later, it's right here, part A, even or odd degree. Part B, we're going to talk about the zeros. That means the roots, okay, of the graph. It's kind of hard to tell where the x-axis is, so you might want to draw it in. It's right there. So the roots are where it crosses the x-axis. It's solutions, right? There's 1 here, 2, and then 3. So I'm just going to write those. I'm not necessarily writing them in y-intercept form. I'm just going to list what they are. This 0 right here is a -3. That one is -1, and that one is 2. And then if you look on the top left piece of information under the zeros, it says, if the graph bounces or turns, that means an even multiplicity. If it crosses through, that means odd. Here's what I'm talking about. At this 0 right here, the -3, the graph is crossing through there. When a graph behaves like that, it means this 0, this factor that gave me this, has a multiplicity that is odd. Okay, and here, let me show you from the warm-up an example of multiplicity. If we go back to this equation that we had at the beginning of class, this exponent right here, this is a multiplicity of 3. What would this factor's multiplicity be? 1. This factor's multiplicity, well, that one's different because it's squared. So that's what we're talking about when we talk about multiplicity, being even or odd. Okay, its exponent is an even number or its exponent is an odd number. So for the 0, -1, what's the behavior there at -1? The graph bounces, it turns around and goes in the opposite direction. So when that happens, your multiplicity is even. Which means it's at, well, I'll talk about that in a second. At the 0, that's +2, even. Bless you. The multiplicity is even. What else is B asking us? C, state the minimum possible degree and write it in factored form. There is more than one way to figure out the degree. One thing that we learned yesterday was count the turning points and then add 1. So if we were to find the turning points here, here's a turning point, here, here, and here. That's 4, and so the minimum degree is going to be 5. So 4 plus 1 is 5. So that's one way of figuring that out. But this section here, this part C, is also asking us to write it in factored form. And here's how we do that. We look at the zeros and their multiplicity. This first 0, -3, what factor gives me a 0 of -3? We talked about this during synthetic division. If -3 is a 0 or root, it came from what factor? Remember? What do factors look like? X plus something, x minus something. X plus 3, right? You remember, this is the 0 form, this is the factored form. So if you know the 0, you know the factor. Now this factor, or this root, has an odd degree. We don't exactly know what odd number it is, so we're going to put the least minimum odd. What's the smallest odd that you know? 1. Okay, so it's got at least 1. It could be 3, it could be 5, but it's at least 1, just judging from the behavior of the graph. For the second root, the -1, what's its factor? X plus 1, and what's its minimum degree if it has an even multiplicity? 2. And then the 2, x minus 2 to the 2. So those are just minimum possible degrees. And If you add up those exponents, what do you get? 2, 4, 5, which corresponds to our, when we use the turning point rule. And then I think that's all that C asks us for. And D asks us to estimate the domain and range. The domain is all x values that will work for this graph. What would you say? All the x values that would work. What would work? All real numbers, right? Or negative infinity to positive infinity. And that, okay, so that's the domain. I should have put a D there. And the range, the graph is going down forever and up forever. So what are the y values for the range? Negative infinity, positive infinity. Or all real numbers, symbol, whatever you like. Take a moment, one little thing at a time, and do that second problem. Here we go. So I'm actually a terrible singer. One time after church, my husband, he was like, do you even try? I was like, yes. All right. So now I make sure I'm surrounded by all the loud people before I sing at church. I'm like, is everyone loud? Okay, I'm going to sing. Nobody will hear me. All right. A is asking us what? I can't remember what they stand for. Okay, whether the degree is even or odd. What'd you say? Even. You got the last one right. So even, because what's up with the M behaviors? They're the same. They're the same. Even. All right. B is asking us for the zeros. Give me the zeros. All right, -3, -2, 1, and 2. All right, and then we want to talk about what their multiplicity is. And the reason why we want that is because it helps us determine the exponents for the factors in the next step. And the multiplicity we know by the behavior of the graph at the point. Not what's happening before or after necessarily, but what's happening right here. Is the graph crossing through or is it bouncing off? Crossing. So what kind of multiplicity is that? Odd. At -2, it's bouncing. So that's even. What about at 1? Odd. And 2? Okay. So then when we do in the next step the minimum degree, if you're doing the degree first, you count the, yes sir. Y is a, okay, so if the end behaviors are the same, they're going in the same direction, that means the degree is going to be even. Just like a parent, like this is x squared, right? So an even degree, the lines are the same, or they go in the same direction. For C, we want minimum degree. We can count the turning points. It turns here, it turns here, it turns there, here, and here. So that's 1, 2, 3, 4, 5. What do we do with that number? We add 1. So minimum degree is 6. And we'll double check that here in a second when we do the factored form. Oh, thank you. It's not that I mind people are listening to me. It's that I mind that other people are trying to hear me and they can't over talking. That's really my biggest concern. So stop with this, so other people can hear. This -3 right here is a 0. That gives me a factor of x plus 3. Yes, with a minimum exponent of 1 because it has an odd degree. -2 gives me this 0 with a minimum degree of 2 because we said even. And then x minus 1 to the 1, and then x minus 2 to the 2. And right here at this step, if you added up all the degrees, 3, 4, 6, it's a double check what that degree you got in the first part of the problem. And then the domain is what? And also yesterday when we first were talking about polynomial functions, I don't know what's up with my thing. When we first, okay, when we were first talking about polynomial functions, one of the properties was that the domain was negative infinity to positive infinity. Now the range doesn't have to necessarily be that. The range is your lowest value to your highest. So what is approximately the lowest value there? Yeah, I like negative 50 or 49 or just something averaged. I mean, just something close. One thing I want you to look at your symbols. Did you use a bracket here? Please. Yes. Now you are, right? Bracket. Okay. Very good. Thank you. Perfect. What's its highest boundary? Infinity. Does infinity get a bracket? No. All right. Any questions? Because we're done.